Okay, so this would be the second video of the ProdCons. This will clear up a lot of questions that you had, as far as the setup and stuff of that nature. Just remember that the main focus points are setting up your I/O tree properly in both processors. What we will do, so what I've done too is I've shrunk in processor 1, I've shrunk the ProdCon. And I did that because of the limitations that are on, the emulate chassis, because of the fact of, like if I went to properties and configured, I'd have to increase some stuff on it. So without doing that, what I wanted to do is just show that, how it's done. So let's quickly go offline. Okay, so we're offline now, and we're going to add a better naming culture. So processor 1 to processor 2. And this will be our produced. So what we'll do over here in our data type is we want to pick our data type that we made, and so now we have the data type of the user defined that we made. Okay, so again, go back to edit and then base, and this will be the produced. Click apply. Okay, so then in this scenario, we're going to add processor 2 to processor 1. So in this scenario, we're going to add the same thing. We're going to be ProdCons, right? We're going to be the data type that we made in the user defined down here. We're going to accept it. And we're going to make that a consume, but we need to do that first again in our other program. So let's go offline. I want to shrink this just like I did in the other one. So what I want to do is basically take this down to 20. I want to take the dents down to 20 as well. So we'll put that at 20, and then we'll keep the bools at 96. So basically our flags. Okay, so with this done, so we'll put processor 1 to processor so the spelling is off. Processor 2, and this is going to be again our data type, our ProdCon data type that we made right here. All right. Okay, so this is going to be the stuff from processor 1 to processor 2. So let's go ahead and set that to a consumed data. Okay, so we'll call that processor 1 to processor 2. And the RPIs will keep it 20. So that's basically how fast they will talk between the backplane. Okay, so we'll put that, we'll apply, and then we'll make our second tag, which is going to be processor 2 to processor 1. Okay, so this is going to be again the data type that we had, so make sure you use that. And this is going to be a produced, right? And this is because we're producing it. We're producing it from the second processor, right, to the first processor, but we're using our data type. We're receiving the data from processor 1 to processor 2. Okay, so let's go back into processor 1. Okay, so in processor 1, we're going to go to edit, we're gonna put in the consume data. We're gonna select our producer, right? And then we're gonna say processor 2 to processor 1. And this is going to be the data that is produced from the processor 2 to processor 1, which we're in processor 1 right now. Again, the RPIs, which is how fast it will talk back and forth, we'll set at 20 as a default. You may have to raise that in the real world, depending upon how deep you are in your I/O tree. So if you're like, a couple layers deep, and then you're going through a Ethernet card, and it's going to another Ethernet card, and your bridge gets so big. But for our instance, we're going to keep it quick. Okay, so now that we have those set up, it's pretty easy to tell who's who and who's what, or what's what. We'll go ahead and download both of these, right? So we'll download it. And click download. And what I'll show you too is, I described to you before, if it's not properly lined up, that you will get a triangle here. Well, I don't have anything downloaded to processor 2 right now, so I wanted to show you that. Okay. So you notice how down here it says it has a triangle on the processor 2. And if I click that, it will tell me where the problem is. So right here, see, it tells me that processor 2 to processor 1, that symbol is not found. So I wanted to kind of highlight this in the second video and basically kind of how to troubleshoot it if you have any trouble. So now let's go to processor 2 and let's download it. And that should clear up that error because obviously we have it set up properly. And if we don't, hey, we'll fix it. I mean, that's part of what this whole training program is about, is getting you the proper information that we can so that you can build and troubleshoot things how the best way you possibly can, right? To really get your end game as high as you can go. Okay, so we should go back to processor 1 and see it cleared it up. So we had everything set up properly. But had we not had everything set up properly, it's as simple as clicking on that, raising the bar down here, and checking out what the fault said. So, with that said, the data that is being sent from processor 2 to us is, we have no data sent right now, right? So let's do that, and let's expand that in the same processor. Or in the next processor. So processor 2, or processor 1 to processor 2. Again, these are the dents, right? So what we'll do is we'll come in and add this. We'll load this value into a different tag. So processor, we're in processor 2. Right, so make sure you look at where you're at right here. That little arrow over here. We're in processor 2. So we want to use this, and then we want to use our first dent. Okay, so now if we go to processor 1, we should see values into that first dent, right? Okay, so let's go into the produced and consumed, and let's do the same thing in this processor. Okay, so we'll pick our processor 1 because we're in processor 1, right? Well, this is going to be the produced over. We can expand this over if we want to see more. Put that in there, and we'll be sending data over there to processor 2 now. Okay, so let's go to, and okay, so we have, and if you want to see it slightly different, like if you want to make sure that this is talking like completely different, let's do this. Let's just to clear up any kind of question. Let's use data 4, so you can easily distinguish that this is not, and so this is writable data now. Actually, I have to clear it in the other processor. Let's go to, okay, so produced, let's go right here, and if I put that at 0, it will be at 0 in the other processor. So again, we're using the stuff we're seeing from processor 2 to processor 1. We're using dent 0, and we're using dent 4 on processor 1 and processor 2. Let's go to processor 2. Processor 2 is reading dent 4 now. Okay, so and right here we are using dent 0 for the talking to the other processor. So you see, the way I normally do things is I would name it in a naming culture of this manner, so that I can easily distinguish which processor that I'm talking to and talking from. So I'm talking from, in this case, processor 2 is the processor 2 to processor 1. This would be the produced data, right? Produced data. Okay. In the processor 1 to processor 2, being that we're in processor 2, right? This would be the consumed data. Consumed data, and you look at what you're consuming right here. All right? So you're consuming the data from processor 1 to processor 2. And again, you can name this whatever you want to. You could name it something completely different. The tag right here, this name and this name do not need to match up in that processor. It just needs to talk. It needs to know the remote data that it's actually looking for. This name and the name inside the other processor have to line up perfectly. But this name and the one into the processor you're actually in doesn't necessarily need to line up. I like to keep it like that way. Keep it that way just to keep out any kind of confusion and make it easy for anybody coming behind me to read. Okay, so if that kind of clarifies that, processor 1 to processor 2, and then of course we're not using the produced time and consumed time anymore, so that can all be zeroed out, right? So go on the other one and we can zero that out. So if we go back to the other processor, it's everything zeroed out now. So that's everything talking back and forth, you know. So again, it's pretty self-explanatory from that point. Hopefully video 2 cleared up a lot of questions that you had. You know, setting up the produced and consumed, making sure that, you know, you use the produced data, and you can alias this as well. So if you wanted to do this, let's see, let's copy this. Let's just blow this away. Let's say produced time out. Okay, right? And then we'll come in and put alias, and then we'll paste this in here. Okay, so in that token, it's produced out. Same tag, it's just alias now, right? So if somebody comes behind, they can say produce timed out. Okay, so this is produce timed out, and this is processor 2 to processor 1. Oh, so okay, I'm in processor 2. Okay, so this is the stuff I'm sending out. So see, it makes it easier to read. It makes it just that much more user friendly for the person behind you, and that's really the end goal, because you don't want to be the guy that is programming that nobody can understand. So again, let's say so produced time out. Yeah, let's just call it time out. Okay, so again, base, change that to alias, put the data in there, and we are talking. So again, they can come behind and say, hey, this is the produced timeout. And again, the naming culture could be different. It could be produced data out or whatever. But the point of it is it's easier to read. And so somebody sees this, they can see that it's produce timeout. Okay, so it's produced from processor 1 to processor 2, and it's dent 4. So if I go in processor 2 and look at dent 4, that's what I'm getting. So whether you use an alias or you don't use an alias, it's completely up to you. I think personally it makes it it makes it so much easier to read. So I just wanted to kind of highlight that. And again, the end goal here is to get you the best experience and the best exposure to what we're talking about in this training program, this training event. So in the process of that, hopefully you got a different perspective to look at things, and hopefully you got the base understanding of produced and consumed. So we will be using this probably a little bit differently in other programs later on, like in the more advanced stuff. But to go over this lightly is what we've done in video 1 and video 2 of the produce consumed. So hopefully that was helpful, and it tied everything together for you. So again, we'll pick up on the next section, and what we'll do is we'll start, we might dig into like 1 or 2 more things and then get into add-on instructions. I think we'll probably go ahead and do add-on instructions next, being that ladder logic is pretty much the common logic that everybody uses, and I think it'd be beneficial that way. Just go ahead and do add-on instructions next. Okay, so all right, to wrap this video up, just want to clarify that like I said, this is pretty easy to read, and I think it is. So just make sure you note the processor, how to set them up in the IO tree, how to set up the tags, and how to find the tags. So let's look at consumed. This is everything consumed in that processor, right? So if I want to just quickly find that, I can go right here. If I want to look at what I'm producing, I can quickly go in here and see the same thing, right? Or if I want to look at everything all together, however you want to do it. This just gives you an easy way to kind of troubleshoot it. If you want to see what you're producing, consuming, then you can use this for much more stuff than that. But anyway, so just to kind of close this video out, like I said, this is produce and consume conclusion. So hopefully this gave you a lot better perspective on how to set things up and troubleshoot it. And keep on the next video, and we'll probably be getting into add-on instructions. So I look forward to seeing you there. Thanks.